Yes, today we are going to talk about the applications of specific heat capacity. So, first of all, we must understand that if a body has more specific heat capacity, what happens? If a body has less specific heat capacity, what will happen to it? Or how it behaves? So, that should be very clear. So, let us talk about the three applications, right? Three applications. Number one, water in oceans. Water in oceans, right? So, however, here our key point is water specific heat capacity. So, water heat specific capacity is more, right? So, what is the meaning of that and how it helps us? So, please try to understand. Water specific heat capacity is more. How it helps us? What is the specific heat capacity of water in CGS system? 1 calorie per gram degree Celsius, or that equals to in SI system, what we can call 4180 joules per kg Kelvin. Okay, this is a specific heat capacity of water. How it helps us? So try to understand it. In Earth, most of the part is occupied by the water. We know, right? So at the equator, at the equator. So whenever the midday, in the midday, you can expect the more heat can be absorbed by the water in the oceans. So if specific heat capacity is less to the water, what might be happen? ఆలోచించండి. స్పెసిఫిక్ హీట్ కెపాసిటీ తక్కువ ఉండింటే వాటర్కి ఏమైండేది? సో వెరీ సింపుల్ థింగ్, వాటర్ టెంపరేచర్ చాలా హైగా రైజ్ అయ్యింది. వాటర్ టెంపరేచర్ రైజ్ అయ్యింది. సో దాంతో ఏమైంది? సో ఓషన్స్లో ఉండే వాటర్ అంతా కూడా వెరీ క్విక్గా ఫాస్ట్గా టెంపరేచర్ రైజ్ అయిపోయి ఈ చుట్టూ ఉన్న మంచు కొండలు ఇవన్నీ కూడా కరిగిపోయి. ఆర్ గెటింగ్ దట్? సో బట్ ఇట్ ఈస్ నాట్ హ్యాపెనింగ్. It is not happening. Why? Because it is having the more specific heat capacity. So due to that, what happens? Due to this, what happens? We have to understand rate of rise. Rate of rise is slow. Specific heat capacity is more. You are saying this rate of rise is slow. Means it is not quick to raise the temperature. Like I can say it's a slow anger, like because it is not quickly rising. It rises very slowly. So due to that, what happens? And it is having the large quantity of water in contact. So that's why the heat can be spreaded to the remaining parts of the sea water. See, ఈక్వేటర్ దగ్గర టెంపరేచర్ రైజ్ అయ్యే ఛాన్స్ ఉన్నా కూడా రిమైనింగ్ పార్ట్ లో వాటర్ ఉంది కదా, రిమైనింగ్ పార్ట్స్ ఇక్కడికి మోడరేట్ గా టెంపరేచర్ మెయింటైన్ చేసేలా హెల్ప్ చేస్తుంది. సో ఇట్ హెల్ప్స్ టు మోడరేట్ టెంపరేచర్ మెయింటెనెన్స్, మోడరేట్ టెంపరేచర్. Got it? So why it is happening? Because of its specific character, that is high specific heat capacity, right? So due to this, what are the benefits? And due to this, it is called the oceans are thermal reservoirs of the earth. Okay, thermal reservoirs, or it can be also known as storehouses of heat. Storehouses, right? Heat storehouses of earth. ఎర్త్ లో ఎక్కడైనా హీట్ ని స్టోర్ చేస్తున్నామా అంటే ఎస్, ఇట్ మే బి దట్ ఈస్ ఇన్ ద ఓషియన్స్. That is in the oceans. Because of that specific heat capacity of water, this is happening. right? It is one application. Now let's go to the second application. Second application. Let us talk about watermelon. Watermelon. So watermelon ని ఫ్రిడ్జ్ లో ప్లేస్ చేసిన తర్వాత ఒక 5 minutes లో 5 minutes లో మీరు బయటకు తీసి if you want to take it out, if you want take that food, will you feel that cool? ఒకవేళ మీరు ట్రై చేయకపోతే వాటర్ మిలన్ అవైలబుల్ ఉన్నప్పుడు యూ కెన్ సీ దట్ యూ కెన్ ట్రై ఇట్. ఇట్ టేక్స్ లాంగ్ టైమ్ టు takes long time to cool. Are you getting? And simultaneously takes long time to lose its coolness. Are you getting this? Why it is happening? Why? Because here itself we are saying the watermelon, when compared with other fruits, watermelon has more percentage of water. More percentage of water. So due to that, what happening? The whole fruit is going to be behave like water, because already we discussed a lot in the above point. The water in the oceans, because of its specific heat capacity is more, it is taking more time to heat up and to cool down. So that the same thing is happening in case of watermelon. So you got it? So because of high specific heat capacity of water, you understand it? The key point is high specific heat capacity. High specific heat capacity of water. So watermelon is taking more time. So that is the reason why we are talking about specifically in case of watermelon about specific capacity. Next, another thing, maybe in sometimes in your life you may experience this. So that one is the samosa. So samosa, when you eat the samosa, okay, when it is taken from the oven, okay, micro oven is తీసుకున్న తర్వాత, outside it may be seems to be it is cool, but inside when you are hungry, just if you take a bite, you may feel that more hot. Why? Because so if you think about this samosa, inside whatever curry is there, so you can understand outside thing has a different specific heat capacity, inside thing has different specific heat capacity. Outside wheat, right? Outside wheat. So this curry. So that's what you can understand. This has more specific heat capacity. This has low specific heat capacity. So that's why what you can understand it. What you can understand from it. So outside cools quickly. Outside cools quickly. And what happens to the inside curry? Inside requires more time. More time to cool. So that's why the specific heat capacities are different in one substance. So how it behaves, that example you can understand by using the samosa. So whenever you are saying it, the specific heat capacity, what you are going to understand, it should be very clear to you. When after discussing these applications, you must have the clarity. So that is nothing but the degree of reluctance. The degree of reluctance of a substance, right? Of a substance. In what case? In what case? In raise temperature. In rise temperature. You understand it? So, I will give an example to understand what is the meaning of this. The degree of reluctance is more, the rise of temperature is going to be taking more time. If degree of reluctance is very less, the rise of temperature is going to happen very quickly. That is the meaning of, just to say, what is the specific heat capacity. So this degree of reluctance you can take as what? Specific heat capacity. Specific heat capacity. That is the specific heat capacity and applications. Now, based on this understanding, you can think about, okay, wherever you are using some substances by this specific property, that is specific heat capacity for different substances. Okay, thank you.